Here is the next example. Here he's asking us to find V2 and V3 by using mesh analysis. Okay, so step one, we always go with loop current. So I'm assigning I1, I2 in loop 2, I3 in loop 3, I4 in loop 4. Okay, now if you look at loop 3 and loop 4, we don't need to apply KVL since there is a current source in the outer branch of that loop. So here, this outer branch, I have a current source. Here also, outer branch of the loop, there is a current source. So loop 4, I4 equal to 1 ampere, loop 3, I3 equal to negative 2 amperes. It's negative because my I3 is flowing in the opposite direction. Now loop 1 and loop 2, we need to apply KVL. Loop 1, apply KVL, minus 20 plus 10 I1 minus I4 plus 5 times I1 minus I2. Okay, after simplifying it, I end up with 15 I1 minus 5 I2 equal to 30. Same way, loop 2, also apply KVL. If I apply KVL, minus 40, I'm going in this direction, so I'm entering the negative terminal, so that's a negative. Again, we need to assign positive and negative signs. I forgot to indicate. So minus 40 plus 20 times I2 minus I3 plus 5 times I2 minus I1 equal to 0. So I know I3 equal to minus 2. I substituted that, end up with 25 I2 minus 5 I1 equal to 0. Minus 40 plus 40 equal to 0. Now what I did, I took equation 3. Here is my here is my equation 4 of minus 5i1 plus 25i2 equal to 0. I'm multiplying that with 3, so I end up with minus with 3. Okay, I end up with minus 15i1 plus 75i2 equal to 0 after multiplying. Now this is equation 3. What I'm doing, equation 3, and probably I will take this as equation 5. Okay, I'm adding those two equations to find I2, end up with I2 equal to 0.428. I substituted that value in equation 4, end up finding I1 equal to 2.14 amperes. Now the goal is finding V2 and V3. So in the given circuit, to find V2 is nothing but voltage drop across 5 ohms. Can I say V2 equal to 5 times I1 minus I2? Why not I2 minus I1? Because whenever you say the voltage here V2, that means that's a resistor, so it is consuming energy, so current must go down. Which current is going down? I1 is going down, I2 is going up, so this must be I1 minus I2. So V2 must be 5 times I1 minus I2. Same way, V3 equal 20 times I2 minus I3. So if I substituted those values, end up with V2 equal to 8.57 volt, V3 equal to 48.56 volt. Now here is another example. Here there are two loops. The question is find Vx by using mesh analysis. Loop 2, as long as there is a current source in the outer branch of the loop, we don't need to apply KVL. So that's what I did. We don't need to apply KVL since there is a current source at the outer branch of the loop. I2 equal to minus 3Vx. So Vx, similar to the previous case, I can write it as Vx equal to 6 times I1 minus I2, the current passing through it. Substitute equation 2 in equation 1. I end up with the I2 equal to or minus 18I1 plus 17I2 equal to 0. Now loop 1, apply KVL. So if I apply KVL for loop 1, minus 40 plus 12I1 plus 6I1 minus I2 equal to 0. Okay, so I have the same equation here, minus 40 plus 12I1 plus 6I1 minus I2 equal to 0. When I simplify it, 18I1 minus 6I2 equal to 40. Now I'm adding equation 3 and equation 4. This is equation 3 and this is equation 4. I'm adding them. I end up with 11I2 equal to 40, I2 equal to 40 over 11, 3.636. So minus 18I1 plus 17 times I substituted I2 value, so that's equation 3. So I substituted I2 value in equation 3, end up with finding I1, end up finding Vx equal to minus 1.21 volts. Okay, with this I'm done with the mesh analysis. Probably next videos I'm going to make super mesh analysis. Thank you.